Hello, everybody. Good to see you. I hope your building is going great. So, real world assets have never been more real. So, Andre today will walk you through the building blocks of building a real world asset. So, today we'll build a house and we will collateralize it in DeFi, all on chain. So over to you, Andre, and let's have a great time.
Cool. Thank you, Tatiana. Hello, everyone. If you can drop like GMs or where you're tuning in the chat, so I can know if you can hear me, that would be great. But yeah, as being said, today we're going to tokenize real estate. We will create a cross-chain NFT out of that real estate. And then we will use that NFT as a collateral to get a loan in testnet USDC against it. So that should be pretty fun. We're going to use CCIP, Chainlink functions, Chainlink automation, and Chainlink price suites all together. Yeah, let me quickly share my screen actually. So you should be able to see tokenizing real world assets slide. It's going to be a hands-on workshop. It's going to be a long one. It's going to be a bit more advanced. And as Tatiana said, I'm going to give you a building blocks of how you can build it by yourself instead of like literally copy pasting the code. All the code is there. I'll share with you. But we're going to talk more about designing the app. We're going to have like a lot of whiteboard sketching instead of like plain coding, which I think that's more beneficial for you. So you can create your own tokenized real estate or tokenized rare comic book or tokenized watch or whatever. So that should be pretty fun. And yeah, I'm using more than one chaining service, actually 4 chaining services because I need it. So that's will also be can be like a cool idea for you for some special incentive when you are submitting your hackathon project. Okay, cool. So let's quickly start with representation. And also I'm going to drop you code in a chat so you can keep cloning, because this is the code we're going to work during the today's workshop. I'm going to put it right here. So yeah, today's topic is about tokenizing real world assets. More specifically, we're going to tokenize real estate. But before we do that, let me hide that banner. So we first need to understand what real-world assets are. And real-world assets in blockchains are digital tokens that represent physical and traditional financial assets, such as currencies, commodities, equities, bonds. So as I said, real estate, rare comic book, watch, whatever, that you can tokenize and then bring on-chain. And yeah, to do that in a meaningful way, we need real-world data. And with Chainlink, we can connect real-world data with smart contracts on different blockchains. But we need to do that right in a secure manner. Okay, cool. Let me quickly go to the next slide. So this is essentially how we are going to tokenize the real estate today. But this also can serve you as a framework how we can, in general, tokenize real-world assets in 5 steps. So the first step is to select an asset. So what's that going to be? Again, real estate, rare comic book, whatever. Today we're tokenizing real estate. So then you need to specify the token because like we're tokenizing in real estate. So tokenizing, we're going to specify a token. So which token is going to be fungible, non-fungible? And then when you select between those two, then which token standard? Because like for fungible, you have like ERC20s, ERC777, whatever. Then for non-fungible, you have like ERC721, or you can want to mix it with ERC1155. So that's all about you deciding which token standard you're going to pick for your particular use case. Today, I'm using ERC721, so regular NFT, but I'm going to make it cross-chain. So I can move my asset across different blockchains using CCIP. And make using burn mint token mechanism. We'll talk about that, but essentially I want to do that so I'm not limited to only one chain, so I can like do more fun stuff with my tokenized real estate. Then step number 3 is to select the blockchain. So do you want to deploy to your private chain to public chain to L2, L3, wherever. As I said, I'm going to start with on Arbitrum Sepolia, and then I'll try to move it to Sepolia, Ethereum Sepolia, and then take a loan there. So I'm going to use my tokenized NFT as a collateral to get USDC. But if you create like a cross-chain version of your token, then initial blockchain is cool. You're probably going to start with your private chain, but essentially you don't care that much, because with cross-chain token, you can just move it around blockchains using Chainlink CCIP in a secure manner. So that's like huge unlock. Then number 4, of course, off-chain connection. So to tokenize anything from the real world, you actually need connection with the real world. I'm going to use Chainlink functions to get all the details about my real estate. I'm going to store it in NFT metadata. And then I'm going to use Chainlink functions to get all the details, price details about my real estate, like initial price, or current list price, tax assessed value, all those values, because then my lending protocol will use these values to actually calculate the valuation of my real estate token, and then it can give me a blockchain loan, right, on-chain loan. So that's something that you need to think of. Also, you can use proof of reserve feeds if you're tokenizing something that has like proof of reserve feeds available by Chainlink, and that way you kind of you have even more secure way to get the actual value of your tokenized assets. That's really important. And finally, issuance. Once you tokenize your real world assets, you kind of need to issue it to correct addresses and entities on chain. For the sake of this demo, and because this is an educational workshop, we're just going to assume that owner can mint an NFT to Alice, and we don't want to bother with proving that Alice actually owns that real estate in real life, etc., because this is out of the scope of this workshop. But that's also something that you need to think about it, because this is an extremely important step, and it's really hard and important to do it right. So I'll also link to like 2 URLs in the README file of that repo that we're going to use, alongside other URLs that we're going to use. But that first 2 are actually from the Chainlink blog, where all of this stuff are explained in detail, especially challenges with issuance. So I encourage you to check that. But for Hackton project, like just assuming that owner can mint an NFT to Alice address, it's fine enough. Okay, cool. So what we're going to build today, so as I said, we're going to create tokenized real estate. So we're going to create like a cross-chain NFT out of real estate. We're going to use Chainlink functions to connect to the Zillow API. Zillow API can provide us a bunch of details about a dummy or a mock real estate, another real one. It's actually they have like a mock endpoint which you can use without API keys. So that's like really cool for like mocking and initial tests. Again, after that, you have like paid versions where you can get details about actual real estates. But this is how we're going to tokenize the real estate, and then we're going to create a real world assets lending protocol where we can use that token as a collateral to get a loan in USDC, testnet USDC, which we can also transfer using Chainlink CCIP natively. So that unlocks us like a lot of possibilities and what we can do. As I said at the beginning, this is going to be all the building blocks for you. You can use the code I created. It's going to probably work, but it's much more meaningful if you understand what I'm doing and then try to frame it into your use case instead of like just git cloning, copying, and that's how you're going to faster learn about this stuff. Because again, I started with the blank whiteboard and started drawing and playing with different components of Chainlink until I created this. So, I learned a lot during that process. So if you just git clone my repo and copy it, use it, you're going to miss that learning process, which is important because this is, again, advanced stuff. It's not that straightforward like other use cases we had so far. Okay, cool. Now that we covered that, let's go through our workshop agenda. So as a first step, we're gonna create a dynamic cross-chain NFT. So once again, we're gonna create a regular ERC-721 contract and then cross-chain it using Chainlink CCIP. A similar thing we've done on the CCIP masterclass number 3, cross-chain NFTs on Arbitrum. So we're going to actually reuse that contract in the interest of time. But if you don't attended that masterclass, no worries. I already shared in the README the URL, and I'm going to share it with you again, where you can have like a written guide as a step-to-step tutorial to see what we built there, and we're going to just walk you through the code once again. After we created like an NFT smart contract, cross-chain NFT smart contract, then we're going to connect it using the Chainlink functions to the off-chain world, to the Zillow API, which can provide us details about real estate. And we're going to use real estate name and media file and country and address, year build, lot size, square feet, total number of room, whatever you want. Actually, I'm going to just use 3 of these components. I'm going to explain it to you why later. But this is all the stuff that we're going to populate as an NFT metadata for our cross-chain NFT token. So all the NFT metadata will be there. And then when you go to NFT marketplace like OpenSea, you can see all the details about your house. And we're going to do this during the issuance phase. So when owner mints an NFT to Alice. And also there will be a function to get price details. So list price, original list price, and tax assessed value. The original list price is something that cannot be changed. List price can be changed by the owner based on the current market conditions, and tax assessed value is changed actually dynamically from the outside outside entities. So that's something that we cannot. That's something that value cannot manipulate. So this is cool enough so we can use these 3 values to create our own math formulas for our DeFi protocol, dummy for educational purposes, of course. So that's what we're going to use to calculate the valuation of the asset as well. Then when we connect with the outside world, we're going to have that issuance process where we're just going to mint an NFT to Alice. As I said, this is a tricky part and a hard part. But for hackathon purposes, it's fine to do it right like this or however you want. But you need to have some kind of mechanisms to prove that the asset is owned by that specific entity in the real world, and also what if Alice compromised her private keys and lost the token, etc. So this is a lot of questions how you're gonna do this step right. So just keep that in mind. Then we're gonna create a real world asset lending protocol. So we're gonna just use testnet USDC. Again, providing that NFT as a collateral and then getting USDC in return. How we'll calculate which amount to get in return? Where again, we're gonna use Chainlink functions to get price details from the Zillow API. As more precisely, we're gonna configure Chainlink automation, more precisely time trigger Chainlink automation, which will call Zillow API to get these price details every single day, so on 24 hours interval, and we'll just store the details about price on chain, and then our real world asset lending protocol can query the details about prices and calculates valuation, loan threshold, and liquidation threshold. These are all important stuff. We're going to get them in a minute. So how we're going to calculate valuation? We're going to use list price, original list price, and tax assessed value, as I said, and we're going to assign them different weights. And then we're just going to you can set all the weights to 1. Then you'll have your formula will become list price plus original list price plus tax assessed value divided by 100. But because 100 is like 100%, but I decided to change that. So the first weight will be 50%. This is the list price, then 30% for the original list price, and 20% for tax assessed value. Again, divided by 100 because 50 plus 30 plus 20 equals 100. And this is how we're going to calculate the current valuation of the tokenized real cross-chain real estate. And because Chainlink automation is constantly calling this Zillow API using Chainlink functions, that valuation is actually changed every single day. And why is that important? Well, first, as a sixth step, we're gonna need to calculate the loan amount. So we come with our NFT as a collateral, and now protocol needs to calculate the loan amount in USDC, which we are gonna get. And the loan to value ratio is essentially loan amount divided by valuation times 100. And then 100%. Then for the loan value, we're just gonna from that value we're gonna select it to 60%. That means that if our valuation is 100 USDC of our tokenized real estate, the best what we are gonna receive 60 USDC in return. GM, Alexander. And liquidation threshold, we're gonna set it to 75%. That means that if our price of real estate at that moment of the loan drops below 75%, drops below 75 USDC, then anyone can call the liquidate function, and then the protocol will liquidate that tokenized NFT. And again, you'll like the same as current lending and borrowing protocols work. USDC will remain at your wallet or wherever, but you will not be able to withdraw the tokenized real estate anymore. So let's actually see this, and let's actually look at the example. So currently our mock API will return these values. So for list price, original list price, and tax assessed value. These are all in US dollars. Important thing to mention is that $1 is not always equal to 1 USDC. So we're going to actually use Chainlink price feeds to calculate the amount of USDC in return using the USD value. So we're going to use USDC in terms of USD price feed. This is really important because you can have inaccurate calculation if you're just using plain USD values. So keep that in mind. I'll show you that later. And these are the weights I spoke about, and these are the two thresholds. So at the moment when Alice takes a loan, this is how we're going to calculate the valuation. So again, multiplying list price with weight, original list price with weight, tax assessed value with weight, and then divided by 100 because that's the sum of all weights. Then when you have that valuation, we're going to normalize it using the USDC to USDC from USD, using Chainlink price feeds. And then that value we're going to multiply by 0.60 because that's 60%. And this is how we're going to calculate the loan amount we're going to get. And at the same time, we're going to store it in the mapping inside the real world asset lending smart contract, the valuation threshold, which is going to be valuation times 75%, so 0.75, which is going to be a little over $500,000 in USDC. So and if from the current $750,000 price drop to this $500,000, then anyone can call the liquidate function and actually liquidate that NFT. So that's what we're going to do. And as I said, using Chainlink automation, we're going to query for price data every single day on each 24-hour time interval. And yeah, that's pretty much it. I'm going to now stop sharing my screen. Once again, this is the URL of the repo. I'm going to display it here. And I'm going to now share my screen where we're going to just jump straight into Visual Studio Code. Okay. So you should be able to see this. Cool. This is the repo I git cloned. If you want to follow along, you can git clone it. But again, like the purpose of this workshop is not to just copy paste my code and run it and everything's fine, everything's work, rather to give you the building blocks that you can gonna use for your stuff. Okay, cool. Let me remove that banner. If you have any questions, by the way, feel free to drop them in a chat. I'm gonna check the chat. I'm gonna check the YouTube chat regularly. But now we're gonna be inside Visual Studio Code. And once I'm start showing the code, I'll try to zoom it in, but if that's not enough, feel free to warn me. Okay, cool. First thing, if you go to README of the repo, let's see how I can preview it. Okay, cool. You're gonna see a bunch of these URLs that I talked about. These are the URLs I used to create this example. So first two are the Chainlink blogs, where you can just read about real-world assets and general problems with tokenization and how Chainlink solves you how Chainlink solved our problem and help you creating and issuing real-world assets. Yes, I can paste the link. Here it is. And the rest are like technical stuff going from the Zillow API, the dummy API we're going to use, to the links in the Chainlink documentation. Okay, cool. Let me see now. Let's actually open this URL. So I'm gonna copy. I'm gonna just stop sharing this screen, and I'm gonna quickly share my browser, if you don't mind. Let's see how I can do that. Let's see. Okay, here it is. Oh, sorry, not about that. Cancel. Give me 30 seconds, please, to share it. Oh, what's going on? Okay, here it is. This is much better. Okay, cool. Let me once again share my screen. Cool. You should be able to see the repo, and I'm gonna just go URL by URL. We don't need these slides anymore. Okay, cool. So the first one, oh, not like this. The first two actually are blogs. So I highly encourage you to check them out later. I summarize them, by the way, in the presentation. Then this is the Zillow API that we are going to use, this property thing. So if you just query this is the reference how it's going to be example response. But if you query this and hit it here, it will going to use it without API key needed. So that's pretty cool. You can print it here, and then you can see all the details about this real estate. There's like a lot of them. Okay, we have 7 photos. That's like text legal description, which is lorem ipsum. What the flooring looks like, laundry features, cooling, etc. Where was the location? A lot of stuff. So you can see that if you scroll it, like there's like a lot of stuff, and I'm gonna just handpick a couple of properties from this API response to populate my NFT metadata. And to do that, let's see, I'm going to use this package. So this is the functions toolkit. If you git clone the repo, that will be installed. But essentially, functions toolkit, Chainlink function toolkit, is the npm package that will help you do stuff with Chainlink functions. So you don't need to like git clone the function hardware star kit if you don't want. You can see that I'm actually using Foundry. So this is the Foundry repo, and I'm using this package with Foundry. So you can use functions with Foundry. That's not an issue. This is how. And the feature I'm looking for here is actually local function simulator, because I want to see, because I want to simulate my API response first before I proceed with testing and everything. And to do that, you need to have Dino installed. You already know that. If you don't have Dino and everything, you just go to functions.chain.link and there's a playground here, which you can also use to start with your JavaScript code. So that's super cool, but this is what I'm going to use. And when it comes to functions, I'm gonna use this. So I'm gonna because I'm gonna return a bunch of stuff from the API endpoint, like a bunch of properties. I'm gonna encode them into a Solidity struct, and then I'm gonna paste that struct encoded using Solidity. Actually, to be more precise, I'm not gonna use struct, but what I'm going to do is I'm going to use ethers, because now you have imports with functions as well. So vanilla JavaScript code is not the only thing that you can do. you can import ethers, and then using ethers version 6, the latest one, I'm gonna encode my property stuff from the API and return that encoded stuff. And then on a Solidity side, I can easily decode them using API decode. This syntax should be familiar with you if you're experienced with CCIP. This is what we usually do on the CCIP receive function as well, where we're decoding the data sent using CCIP because it's going to be all bytes. So this is what I'm going to do. And the rest is pretty self-explanatory. Okay, do we have any questions? Let me quickly check that. Besides excitement that we're dealing with Foundry, no questions. That's super cool. Okay, cool. So the first step, as we said, we're gonna tokenize the asset. So to tokenize the asset, we first need to create like an NFT smart contract. And to create it, I'm just gonna use ERC71 from OpenZeppelin, and I'm gonna add cross-chain flavor on top of it immediately using Chainlink CCIP. So if you click on this URL, this is the Gitbook for masterclass, CCIP masterclass number 3, where we actually build cross-chain NFTs. I'm gonna quickly walk you through it if you haven't, if you didn't attend that one, but you have like, as I said, rating guide here. So how do cross-chain NFTs works? At a high level, like NFT is digital token, blah, blah, but if you want to transfer it across different blockchains, you need to select between one of these 3 token transfer mechanisms. So you can use burn and mint, lock and mint, and lock and unlock. With burn and mint, it's like burnable and mintable NFT. So you're going to burn it on the source chain and on a local chain, and then mint it on a destination chain or a remote chain in the same transaction. Lock and mint is just you're locking instead of burning the NFT. So you're just storing it inside the CCP sender contract and then minting it on the other side. And lock and unlock is if you have like NFT contracts, NFT contracts, and NFT with the same ID issue it already on multiple different blockchains. You're just going to lock it and unlock it in this sender and receiver smart contracts. So you can see over here how that works. I'm going to just zoom into the first part because we're going to work with burn and mint. This is the token mechanism I choose. So I'm just going to always have one entity, one token ID smart contract. Entity of my cross-chain NFT smart contract in existence at the same time, because I'm gonna just use burn and mint all together. And how we're gonna implement this in practice? Let me just zoom out a bit. Actually, now is a good time to share Visual Studio Code because we finally came to the coding part. Good question. How to choose which strategy to use? It's totally up to you and your logic of the overall protocol. So there is no right or wrong answer. These are the three token method transfers that you can pick, and it's just a matter of like what do you want to pick and how it fits into your overall project. So there's no wrong answer. I just picked the burn mint because I find it the most convenient to use. Okay. Let me share my Visual Studio Code, and after I share my Visual Studio Code, I want to switch between screens altogether, so which should be good. Okay, cool. So first of all, how to create real estate NFT. So this is my cross-chain NFT. Let me zoom it a bit. That's too much. Cool. Bunch of imports. I'm using NFT ERC71 standard from OpenZeppelin. Actually, I'm using ERC71 flavored URA storage, which means that I'm going to store my NFT data on chain, and it also using burnable because I want to be able to burn my NFT. Cool. Now let's see if I'm gonna mint this NFT only on Arbitrum Sepolia. So this is where I'm gonna issue it. This is where the only owner is gonna mint an NFT to Alice. And once I created a new token ID, a new NFT, then I can move it between chains using burn mint. So when I do that, like minting is not gonna mint like a new with new token ID and everything. I'm just gonna reuse the same token ID of the token I previously previously burned, but the issue is going to happen on Arbitrum Sepolia. This is important, and a bunch of modifiers. Let's see what we're going to do. Okay, cool. So we have the issue function where only owner, only on Arbitrum Sepolia is issuing the NFT to Alice. How we do that? We're basically creating a function request and querying the Zillow API for the NFT metadata details. And over there in fulfill Chainlink functions function, we are going to actually mint a new NFT. And this is how we're going to do. We're going to issue. Now we have a function to enable chain. Why? Because we want to, as an owners, our NFT to be distributed only on certain chains. Actually, we want to have it on all chains, but I want to specifically say now you can transfer to Ethereum Sepolia first. And to do that, it is simply as populating some mappings. Same thing goes for disabling the chain. And this is the cross-chain transfer from. Now that I have the NFT, I can cross-chain transfer it using Chainlink CCIP. So I will need to specify the address of the owner of Alice, the two address, like Alice address on Ethereum Sepolia, token ID, destination chain selector, so chain selector of Sepolia, Ethereum Sepolia, and how I want to pay for CCIP fees. It's going to be wrap native or a link. You can specify that. And again, you can transfer only to only enabled chain. And then you see you're storing the token URI using this is the view function. So you're just getting the current token URI of token ID. Here, this is basically the data, part of the data I'm sending. You will need token URI. I'm burning it now. So this is extremely important to be non-reentable function. So I'll put like non-reentrant lock on top of it. And now I'm burning it. I'm creating the CCP message. I'm encoding so the receiver is actually my cross-chain NFT address on the other side, not the Alice address. That's the important thing. This is how I design it. You can design it by your own. And then this is the data I specify from to token ID and token URI. And I'm not sending tokens. This is just the CCP extra bytes. And here I'm handling the fee token. And then after all of this fee token handling, I'm finally sending the message CCP send. Cool. After that, the same contract deployed on Ethereum Sepolia when CCP receive function is being called, then you can decode all the stuff from the data field, like from to token ID and token URI, and then mint it and set token URI on the other side. And finally, if you're dealing with NFT stuff, you should be able to figure this out. So this is the support interface. You will need to have this line. So it supports interface IDs for NFTs, for NFT stuff, for any to EVM message receiver from Chainlink CCIP stuff, etc. So if you're doing any cross-chain stuff, you'll need to have this function. Okay, that's pretty much it when it comes to cross-chain NFT. This is just the cross-chain NFT. We're not going into real estate part yet. Let's see if you. Okay, cool. No questions. If you have any questions, just drop them in the chat. I'll check them later. Okay, step number 2 is now to connect with the Zillow API and tokenize it, right? So to do that, I actually have a couple of scripts over here. So we're interested in function source get NFT metadata. Okay, cool. So what I'm doing here is I'm importing Ethers v6. So this is how you can do it with the latest release of Chainlink functions. So you can import any npm package. Like this is literally how you're going to use it if you're having like a real JavaScript. If you're dealing with Node.js on your local machine, this is how you can use it in functions. So this is the syntax basically. Then I'm creating the instance of ABI coder. I'm using functions library to make HTTP GET request to that URL, dummy URL I told you about. And then I'm getting some stuff from the data field. And finally, I'm encoding it into Solidity bytes. And then I can easily decode it using this syntax. So Same thing for we are using for crushing NFT. Okay, cool. Couple of issues that you can have here. Actually, before we go to that, over here is my request config. So this is something that you can just grab from this repo or from the functions hard start kit. Everything's work. I'm specifying the source. So this is my get NFT metadata. I'm also gonna query this one. And I'll just need arguments. I'll talk about that in a minute. Important thing to mention is this expected return type. You're expecting now solidity bytes. So bytes, because here I'm just encoding it into bytes, and your contract expects bytes, and then it can easily decode it into whatever. And this is the general thing that you can use for struct. So you can encode tuples here. You can encode whatever string, whatever data, solidity data type, and you can easily decode it on the other side. This is, this is for more complex stuff. If you want to just return your int of f6 or string, you know how to do that. You're gonna just specify those data types. But in general, with bytes, you can do much more stuff. So I highly encourage you to check that, and you can easily reuse all of this stuff because it's just universal. You're just using Ether's library. Okay, cool. Finally, I have this function simulate script, which is the Node.js script I developed. You can use it. This is how I'm going to run it. But essentially, it's like a Node.js script. I'm just using the Chainlink functions toolkit npm package that I showed you at the beginning, and I'm using simulate script function from it. That allows me to just simulate the execution of a script in a local environment first during the development of the JavaScript code itself. And it exposes three stuff. So response by string. So this is the response that your smart contract will receive. This is the error string that your smart contract will receive. And this is the terminal output. This is basically if you have any console logs in your JavaScript thing, it's going to appear here. Okay, cool. Let's actually run it first. So I'm going to show you something. So I want to now run node function simulate script. And this is the simulation, blah, blah. So first stuff is response. So this is the response my smart contract will get. Second stuff is error string. And there wasn't any console logs. Now, what I'm going to do, let's close this. I'm going to console log the API response. So console log API response. And let's run it one more time. So it's going to be a huge one, you see. So now is that all the stuff that I show you from that website is basically here. This is the API, what API returned to me. So we can see a bunch of stuff that I can just pick. And this is how I can do API response, data, and then address, data, year build, data, lot size square feet. You can also see that there should be like a media. Yeah, here it is somewhere. Let's see, to find media, that's like the picture. Or let's do whatever. Let's do postal code. Let's do postal code. So I'm gonna do const postal code is this, const number of room, let's see, number of units total. Yeah, okay, cool. Let's do const number of units total. You can see right over here 74 total, so that's number, etc. And now I'm gonna, instead of console logging API response, I'm gonna console log all of that stuff. So console log real estate address, year build, lot size, postal code, number of units. Okay, cool. Let me run my script again. So it's same thing. This is the response I'm sending, and no errors. And this is the real estate address, when it's built, how big it is, postal code. So it's like a really big real estate, probably for business stuff. Now let's see if I want to add postal code, which is a number, okay, it's string here, but let's make it a number. So it's unit of f6 and number of units total. So I'm also want to encode unit of f6, unit of f6, and we're encoding postal code and number of units total. Postal code, number of units total. And let's quickly run script once again. Okay, cool. Now we have like 5 different stuff here. So we have 5 different metadata things. Let's actually do const real estate media file, and this is the media URL. This is the image of the. I know that this one is a big one, so I wanna show you something. Just bear with me. So I'm gonna run script again. And we can see, okay, if I go to this URL, I should be able to see the actual picture of this real estate. Now I want to encode that one as well. So it's a long string, once again. So string, and I want to say, okay, I'll need real estate media file because that's for my NFT, blah, blah. Now let's run it one more time. Hopefully I'm gonna break my script finally. Okay, cool, I broke it. So now the response is undefined, but we have an error. It says response is bigger than 256 bytes. So this is the current limitation of Chainlink functions. And if you go to service limits, you're gonna see it. And this is something that you can encounter. So when you're doing simulation, always console log all of this stuff, because if you forget to console log this string, for example, error string, and just run it, and you don't care about thermal output as well, but you care. But never mind, and just run it. You can see, okay, now the response is undefined. Like, what happened? Like, this is perfectly fine code, etc. But if you have the error message here, you'll see that actually your response cannot be greater than this value. This is the current limitation. So this is that you need to find like a workaround around it. So that's something that you can encounter during building your stuff. So please be aware of that. I'm going to solve it by just removing the real estate media file. I don't want to return that. Now, if I run my command again, you can see that I have like the bytes that is easily transferable, and it's like encoded and all that stuff. So I show you that on a previous slide that I want to display the number of rooms, that I want to display the address, the country, etc. But I will need to have multiple functions requests to populate all of this NFT metadata. You can definitely do that because, again, this is just the issuance process where you're populating your NFT with metadata, and you want to have as many as possible. But to find but I found the middle ground here, that these 3 stuff, real estate address, year build, and lot size square feet, are the most important to me, because these are the main drivers for me when I want to evaluate real estate using the DeFi protocol. So this is what I did, and I'm gonna just delete all of that stuff, and my smart contract accepts bytes data that's gonna decode to string and to uint256. This is important. So now let's go to this thing. So my smart contract expects that I'm providing string, which is real estate address, uint256, which is year build, and uint256, which is lot size square feet. And if I encode media file here or number of rooms or whatever, I'll need to then do uint256 number of rooms and then uint256 as well. And now we fix it. So this is how you encode and decode stuff using Chainlink functions. And then, well, possibilities are limitless. I don't like that. So Forge, FNT, SRC, cross, yeah. Foundry for the win, Forge FNT. Okay, cool. Any questions about JavaScript stuff? Let's see. Okay, somewhat intangible. Okay, TP answered that. Okay, cool. Okay, cool. No specific technical questions about what I'm showing. That's cool. You understood it. It's not that hard, right? So it's just the JavaScript stuff. So this is for NFT metadata. And yeah, once again, I encourage you to steal this script if you want. It's like literally 13 lines of code, and you can just simulate any JavaScript code using functions. So that's like pretty cool. Okay, second script that I have is the script to get prices. So it's pretty similar to the previous one. Again, importing gators, ABI coder. I'm actually using Tokenized because I will need arguments. So the difference here is that when automation calls the get prices and whatever, I will need to provide the token ID. So that first token ID that I'm going to issue to Alice, because now for a specific token ID, for a specific tokenized real estate, I need to get price details, right, using Chainlink automation. So I need to have this thing. So if you go to arguments, actually config, sorry, and here the arguments, I hard-coded it to 0 because this is the first token ID I'll have. But essentially, you want to have like a Solidity function that accepts the token ID argument and then create a request. And apart from that, it's pretty much the same thing. Again, API response, making an HTTP GET request. Now picking these three stuff from the data field, like these three properties, and coding them inside a for unit of f6. So I'm going to return token ID plus these three prices, right? Because I need to update the storage details about prices and just return either. So if I want to run this, I'm just gonna now pick a different source, and I'm still in a local environment. And now it's again node function simulate script, and this is what we're gonna receive. So it's much less bytes because we're encoding unit of f6 strings, and bytes are generally long and much, like because of the length of the string, etc. So keep that in mind when you're returning stuff, because you don't want to return memory or gas bombs to your smart contract from the functions. That's a bad design choice. Okay, cool. Now let's go back to the smart contract. So we're now at the step number 2. Actually, we're now at the step number 2. So let's create whiteboard.xcali draw. I like this. It's like super cool. So we can have like whiteboard here as well. So what we did so far, hope you can see this. So we created an NFT. So this is like a regular OpenZeppelin ERC71. And then we added cross-chain features. Like we basically added CCIP stuff using burn and mint, and essentially made this as like a cross-chain NFT. Let's put it here. So that's what we did so far. And now, once we have like cross-chain NFT, we want to, that was like step number 1. So that was step 1. Now, as a step 2, we're gonna connect with the outside world, and here we have how to drive an API endpoint. Let's let's do maybe like this. So this is Zillow API, which can provide me details about real estate, and I'm calling the issue function. So this is the issue, which is making a request to the, actually, let me delete this. I made a mistake. Actually, here in between, we have functions, right? So these is functions. And then I'm doing this. So this is issue, right? This is step 2, so issue. And then functions, query the API returns a bunch of stuff, right? Our script then pick these 3, and here as a return, we will return NFT metadata, and here populate NFT metadata. Right. Okay, cool. That was what we did so far, and this is the code I show you so far. Okay, any questions? Besides that, this is us. Cool, thanks. I didn't know that Xcali Draw has like a VS Code plugin, so I really recently discovered that, so like super helpful. I just doing everything inside that Visual Studio Code. That's super cool. Okay, does CCIP support non-EVM compatible chains? It's designed to be supported. If you go to supported networks, I think at the moment all the CCIP powered test networks at least are like EVM. But when you send like cross-chain transaction, it's going to be EVM to any and any to EVM message. So literally designed to support non-EVM chains like Solana, Polkadot, Bitcoin, private chain X, etc. So yeah, it's just I think so far none of the testnets are like EVM compatible. Maybe I'm wrong. It's a fast pace, but yeah, definitely design. Yeah, and you can check all supported networks here. Exactly. Thank you. Cool. Okay, this is an action question. On what basis are you issuing new NFTs for Zillow? Yes. So as I said, like issuing the real estate NFT is a complex topic. You need to have like proofs, maybe like zero-knowledge proofs using Deco that Alice is the owner of that real estate, right? And then what's the address of an Alice on chain? And then what if Alice's wallet keys get compromised, etc.? Does she lose the tokenized NFT, etc.? So this is all the stuff that are discussed in the two blogs that I shared to you. Right now, Zillow API will return just mock dummy real estate data. And I'm going to use it, and I'm just going to say, okay, owner of this contract will call the issue function and issue one NFT to Alice, and that's good enough for the hackathon project and good enough for this workshop. But in theory, you have all of this stuff that you need to care about. Okay, cool. Now, let's go to step 3, and let's see in our presentation, actually, what's step 3. So we did created cross-chain NFT, we have the off-chain connection, and we actually, step 3 is to issuance that I talked about. So we can see that I already have the issue function here. So that's cool. So let's quickly jump to code for issuance, and then we're going to jump to step number 4, which is creating the real-world asset lending protocol. Okay, cool. Let's go back to the code now. Here is the function of fulfill request. So this is here, fulfill request, and I'm populating NFT metadata. I have this last request ID stored as a storage variable. So this is kind of like for me to prevent front running and everything. So if last request ID set inside a issue function, let's find it. So issue here, here request ID. Oh no, here. Sorry, I'm checking last request ID here, and then in fulfill request function, I'm setting story. Sorry about that. But essentially, I need to compare this with the request ID, and then I'm gonna increment token ID using base 64 and smart contract from OpenZeppelin. I'm gonna create on-chain metadata. So real estate, address here, build, last square feet. These are all traits of the attributes. I have a name, I have a description here. Image is currently empty, but obviously I'm going to use that media URL from the API, etc. And once I have the final token URI, I'm going to mint it, and here set token URI. If that request ID is not set, then its fulfill request actually is handling price update. So that's calling the other script and just updating price details. When it comes to price details, it's over here. So we have a struct like this. So let's go over here. Oh no, like this. Okay, cool. We have struct like this, solidity struct. The reason why it's uint80, 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 and uint256. So uint256 is like extremely long. It's not long, extremely huge value. So all these prices are not likely to be that huge. So you can just package it like this in a storage variable, and now with 3 uint8s, all of them are like in the same storage and solidity. So this is more gas efficient answers for me. actually, before we continue with that, let's run the script one more time. But before we run it, I'm gonna console log it so you can see the values. So console log list price, original list price, and accessed value. And node functions simulate script. So you can see that I will receive like values like this. So it's gonna be what list price is what. So like Vue256 is literally too big of a data type for this. So we can store it in even smaller data types, but like this is fine enough. Okay, cool. So let's collapse this. We will also have Chainlink automation. How are you gonna do this? Let me put this aside. And this is, actually that's cool. let's draw it like this. So this is, can I type? Yeah. Chainlink automation. And now Chainlink automation will every day on each 24 hours. So this is going to be like time trigger. So this is time-based Chainlink automation. And this is what, step number 3.5 or something, because this is step 3. But nevertheless, we'll ping your smart contract, which will again call the Chainlink functions like this. Let's use blue. Yeah, cool. So it will again, sorry about that, it's not that easy. So Chainlink functions to get prices. The name of the function is, let's see, the name of the function is update price details. So update price details, again, creating a function request. As an argument, I'm providing now the ID of the token. So this is really important. So token ID. And if you see, okay, I'm expecting token ID here as an argument. So update price details. And update price details. And then again, querying the Zillow API, returning price details, calculating different script, and finally, we'll just here we're gonna update the price details in an else branch here. So we're gonna store everything in a mapping here. Any questions about this? Can we get a link to the repo after the session? Yeah, actually, it's right over here. So this is what I get cloned. It's somewhere in a chat. So yeah, it's already there. But I'm gonna actually do a git push with the Xcali draw if you want. Okay, cool. And yeah, blogs are in the README. So if you git clone the repo and everything's in the README, so you can check there. Okay, cool. No questions. Perfect. Now, when we have all of these details, and we can easily move to step number 4, which is creating the real-world landing protocol. So what I want to do is to create landing. So I am expecting cross-chain NFT real estate in as collateral and USDC out as loan. Okay, cool. Let me zoom it a bit. So now, when we have like a cross-chain NFT, the rest are just helper function, get, etc. So you can see it's a fairly big code, but this is because of the cross-chain stuff and functions handling stuff. It's not that complex, and it's literally I'm reusing the code we had at CCIP masterclass number 3, so you should be already familiar with it. Now, the new code for this workshop is actually RWA lending. Okay, let's quickly go through it. So first of all, RWA lending needs to be able to receive smart contracts, to receive NFTs. So this smart contract must inherit this interface from Opal Zeppelin, because if don't, this smart contract cannot receive ERC-721 tokens, and if not, let's say if not, ERC-721 safe transfer from reverts. And also keep in mind that safe transfer from is not that safe, because it can be re-entered if not implemented correctly. So just keep in mind about that. So ERC-721 receiver means that I will need to have this function implemented. So on ERC-721 receive, and in the majority of implementations on chain, you will just find implementations like this. So okay, cool. This is my function. It says that I have like on ERC-721 receive selector, function selector, so I can receive NFTs, etc. But it's extremely important to have this check in place. To have this check in place, because I'm now here validating that message sender is only cross-chain real estate NFT. So my smart contract, my real world assets lending protocol cares only about cross-chain real estate NFT and not other NFTs, because we don't have like logic to handle the rest. This is educational dummy repo example contract, etc. Do not use it in production, blah blah. So this is why I put this if statement here. Okay, cool. Yeah, can we please get your Discord to ask additional questions after we try to implement? Yes, it's Andre Chainlink Labs. You'll see I'm pretty active in support and CCP channels, so just tag me and I'll answer. Can we tokenize any real world asset? Yes, that's what I talked at the beginning. It can be real estate, can be rare comic book, it can be watch, whatever. So it just the tricky part is how you're gonna issue it on chain. How does the image get updated since it's already hard-coded as in metadata? In this example, cannot be, but essentially you want to have like a setter function where you're gonna update on-chain NFT metadata, or you can use off-chain NFT metadata. So you're just gonna have like a URL, and then at that URL is gonna be property JSON with a bunch of properties, and if you can change that with refresh metadata, OpenSea, the new image will appear. So there's actually a really good blog post about that. If you tag me on Discord or Twitter, my Twitter is Andre_dev. I'll try to find it in my bookmarks and I'm going to change it to you. For example, vehicle, yeah, you can tokenize the vehicle as long as you can have the way to connect using functions with the real world, and you have the way to prove that vehicle is yours and that's your address on the chain. And what if you lose your keys? On private keys, do you lose a vehicle, etc.? But yes, definitely possible. Okay, cool. Let's go back to the Visual Studio Code, actually. So cool. This is our real world asset lending protocol. So actually, we just need after we just need actually 3 functions, right? So we will need a function to get a loan. So functions needed. So a function to get a loan. So that'll be NFT in USDC out. Then we will have a function to repay a loan. So there'll be vice versa, USDC in NFT out. And we will need a function to liquidate position. And that's pretty much it. Like for this example, for dummy stuff, educational purpose, that's more than enough to have these 3 functions. Let's take a look at them. So over here, I'm hard coding all of these weights and values from this slide. Let me click show that slide once again. So this is the formula for calculating valuation, and this is the formula for calculating loan amount and liquidation thresholds. So this is the logic that I'm going to use. I'm hard coding it in a constructor that's not usually the right way to do it. Usually you would like to have the option these values to be updated by governance or over or multisig, whatever, because hard coding like this is generally not the greatest idea. But to have like lesser code, I did that. So keep in mind about that. Cool. Going back to Visual Studio Code. So the function to get a loan is borrow. The function to repay a loan is repay, and the function to liquidate is liquidate. So we can see that these are fairly simple functions. So first of all, we're gonna calculate the valuation in USDC. Then once we have that normalized valuation, if it's 0, we're gonna revert because something went terribly wrong with calculating evaluation. Then we're going to calculate the loan amount. So that's normal valuation times initial threshold, which is 60. So 60% divided by 100. And this is the loan amount. Then if loan amount is less than minimal loan amount, we are going to revert because we introduce this minimal loan amount as a slippage tolerance variable. So I want to still be in control about loan and thresholds amount, liquidation threshold values, because what if front run market conditions change, sanity tax, whatever. So I would just want to be sure about that. Highly unlikely with this hard-coded scenario, but essentially whatever you do, you want to have slippage protection in place in general. And the same thing for liquidation threshold, calculating it using 75% as an initial low to liquidation threshold. And then again, if now that value is greater than max liquidation threshold, I still want to revert with slippage tolerance exceeded error. After that, and this must be a non-reentrant function as well. After that, I'm transferring NFT in. I'm populating the details about the loan, so borrower, USD amount loaned, liquidation threshold, and then finally transferring out the USDC amount and emitting an event. Why is that needed? Well, when I want to repay my loan, I'm gonna get the loan details from the active loans mapping, and if message.sender is not the borrower, I'll revert. Then non-reentrant again, updating check effects interaction pattern over here, deleting the mapping, transferring USDC in, so this amount loaned. If that reverts, it will revert. Then transferring NFT out of smart contract and just emitting an event. Finally, I'll liquidate. So because automation will constantly on each 24 hours call the Zillow API to update price details. That means that using this script, that means that price detail can change, and we want to monitor that somehow. And if we find the room to call the liquidate function, we can again calculate the normalized valuation, because valuation can be changed on every 24 hours. And if it's lower than liquidation threshold, then we are going to just delete this mapping, delete this entry from this mapping, and now I can never be able to repay my loan, but I'm still left with USDC. So these are the three main functions. Okay, cool. Cool. Question. So why the cross-chain functionality can you borrow against the NFT on the same protocol as you used? Yeah, so cross-chain functionality is like for general stuff, because I tokenize my NFT. What if I want to go to NFT marketplace on blockchain Z or whatever? So this is how I can, lending and borrowing is just an example of what you can do with that tokenized NFT. You can go to NFT marketplace and sold it. You can, like do whatever you want, but with cross-chain functionality, I can be everywhere. It's definitely not needed, but it's much better to have that option than don't. It means we lend 60% of the value of assets. Yes. Let me actually go through the math with you once again. So this is from this screen. We talked about it. So I'm just going to go to exposure really quickly. So we can do it here. So what I want to do is I have weight number 1, which is for list price, and I put it to 50%. Weight number 2 for original list price, this is 30%, and weight number 3 is for tax assessed value, that's 20%. And then I have a function which is current valuation, actually valuation is equal, and then let's put it like this. Whoop. So that'll be weight 1 times list price plus weight 2 times original list price plus weight 3 times tax assessed value, and then all of that divided by weight 1 plus weight 2 plus weight 3. Now, because automation is getting price details every day, this can change list price and this can change. So I can have a different valuation every single day. And if I have a valuation which drops below liquidation threshold, I can liquidate it. So then we used loan amount. Loan amount is valuation basically times 0.60, which is basically 70%, which is like 60% of valuation. In USDC, and liquidation threshold is basically valuation. Oh, come on, 75. So this is 75% in USDC as well. Okay, cool. Now the question is, and we saw that here. So let me quickly run my script one more time. Sorry about that. Okay, here. Oh, actually, here it is. So we have these values, right? Currently. Yep. So we have these values currently. So, and these are all in USD. So the problem is here that now USDC is not equal to USD all the time. And this is really important. So I can have different so I can gain more USDC or receive less USDC, depends, because basically, actually, 1 USDC is not equal to 1 USD, but you get the point, because USDC can go from 0.99 to 1.1, etc. Actually, the good website to do that, to find that, is, let me share that Sorry about that. I thought that I'm gonna stop sharing, but I want to show you something. So if I go to window, yeah, this one, where we build cross-chain entities, right? So build cross-chain entities. Here, if I go to data.chain.link, and I'm interested in data feeds now. And I'm interested on Arbitrum Sepolia or Ethereum Sepolia. Oh, there is no Sepolia details. Never mind. We can do this, and then let's find USDC. That should be at the end. Oops, here it is. USDC in terms of USD. So I want to use actually this price feed because you can see the current answer is 0.999999623. So it's not 1 USDC equals 1 US dollars. We can see, so deviation threshold is 0.1%. We have a feedback, heartbeat, etc. But what I want to see is that, okay, so currently stop sharing my screen and go back to Visual Studio Code. That'll be a window, right? Yeah. So currently, one USDC equals to. So you can see that it's not always the same. So what is the solution for this, right? Is to use. The solution is to use data feeds, right? Okay, cool. And if I go back to my lending protocol here, you saw that I a bunch of time called the get valuation USD. Let's go to that function. So get valuation USD, here it is. And let's quickly analyze it, shall we? So get valuation in USD is done like this. So first of all, we are calculating valuation like this using our formula, which is here. So this is the formula, and this is how you can write it in Solidity. So I'm not using unchecked block here because I don't want to deal with overflows and underflows, but this is how we're going to calculate the current valuation. Then we need to normalize it. How? Then we're going to call the get USDC price in USD, which is talking to price feeds. Then when we have details about USDC price in USD, which is, let me, I will need to share my screen once again. Sorry, I don't want to, but present, share screen. There'll be window. If I go to docs.chain.link and I go to data feeds and find feed addresses, that's 5 price feed addresses. And yeah, this is Sepolia. Never mind, it's the same thing. What I'm interested here in is number of decimals. So we can see this feed is having 8 decimals. And latest answer is something like this. So a little over $1. Right, cool. Why is this important? We'll see in a minute. Share screen, window. Where is my beautiful landing? Yeah, here it is. So Excalibur, you should be able to, yeah, cool. So currently, okay, USDC, USD feed. Number of decimals is 8. USDC as a token has USD has 6 decimals, and example return is this. Okay, cool. So what does that mean? first, let's deal with the feed. So this is the value returned by feed. Let's put it here. And feed has 8 decimals. So that'll mean that 1, 2, 3, 4, 5, 6, 7, 8, and we're going to put comma here. So that means that means that $1 equal to that 1 USDC, equal to this amount of US dollars. This is how we are reading the feed, okay? Because USDC in terms of USD, 1 USDC equals this amount of feed. It's just this huge number without stuff, but we know that it has 8 decimals. Now, USDC as a token itself has 6 decimals. So that means that if I do, like said, I do ERC20 USDC, save, transfer, and then UN256 amount. Now I'm interested in UN256 amount. So if my amount is 1, I'm actually transferring 0.123456, this amount of USDC. So if I want to transfer, okay, you can't see this. Oh, sorry about that. Okay, cool. So if I want to transfer 1 USDC, my amount should be 1 and then 1, 2, 3, 4, 5, 6 zeros, because USDC as a token has 6 decimals, but the price feed has 8 decimals. Okay. Any questions about this? No. Cool. Now, how I'm gonna normalize all that? So here I have a feed decimals which is I'm querying from the contract itself, and I hard coded here, not the ideal stuff, but okay, the number of decimals for USDC because I'm only dealing with USDC. And now normalization works like this. So I basically what I'm going to do is, again, let's summarize all this. So what we have, sorry about this. So we have this list price. So I'm going to just put it here. So we have list price here. I'm going to zoom it a bit. And we have decimals and return here. And we want to normalize all that stuff. So how to do that? Basically, so this is US dollars. So what you're going to do is you're going to do something like this. So 761167. So this is okay. This amount of US dollars, right? You are multiplying by the 1001272. Okay, and now this is the price in what actual price in USDC. However, this is inaccurate because if I do, let's see, let's do it like this. Hopefully this will work. We'll see. So you can also log this. Okay, I need this big number. Okay, so console log this big number and going back to Excalibur. Now this big number is not accurate because if I do transfer, if I do ERC20 USDC save transfer this. This is what? This is actually transferring 1, 2, 3, 4, 5, 6. So you're transferring a lot of USDC, right? Which is not accurate. What you want to do is to normalize all of that. How? If I go back here, you say you want to multiply with the number of USDC decimals and then divide with feed decimals. So that'll be like this value now. So all of that you want to first multiply, then divide to prevent from rounding error. So you're multiplying with 10 times 6 and then divide to this. And now you have like a normalized value, which is not this one, but it's rather the actual valuation, right? So I'm going to just delete all of that. So this is what this piece of code is doing. And when we have normalized valuation, then we're just dealing with actual solidity in liquidate, in calculating the loan amount, etc. Okay, finally, let's see how we're getting the price details. So you can just use latest round data. So you can just use I'm going to comment all this. So you can just use something like this. So there'll be like this, latest round data, and then return UN256, right? This is what you usually do at hackathons, right? But here I went a little bit step forward. So I want to show you a couple of tricks. And what do I care about here? So first of all, I'm doing this try catch block because I'm trying to see if latest round data is for some reason DDLs, but probably not. And then if this is actually denial of service. Okay, never mind. Okay, I have two Ds. Never mind. Then I'm interested in round ID. So if round ID is invalid, I'm going to revert. Then I'm interested in if the price feed is stale. So we saw on that previous screen and data.chain.link the thresholds, the threshold when it comes to price data and also the heartbeat value. So I can get these heartbeat values from the official docs, and I have actually a function that only owner can call that I can update this hard feed, right? So you can see, yeah, I can update the details about price feed, both aggregator address and heartbeat, right? And if the price data is stale, I want to revert, and if not, I'm gonna return the price. I'm not checking if the price is actually 0 or something, because over here, when I'm normalizing the valuation, I'm basically querying for everything is 0. So this price can be 0, or data returned from Zillow API can be 0 or undefined or whatever. So I'm just having that check here, and then basically it's just the rest is just dealing with price data and valuation and formulas and everything that I showed you. The rest is pretty much self-explanatory. So that was like our last check, and I'll just make sure to commit this drawing as well if you want to reference to it. But this is how we created cross-chain real estate NFT using CCIP, chain functions, Chainlink automation, and then lending protocol, which is price feeds as well. And this NFT as a collateral and loans USDC in return. So now is time for questions, if any. I'm gonna stop sharing my screen. Let's see how. Okay, cool. I did it. Yeah. So if you have any questions or anything, so feel free to drop them in the chat. And what if the borrower does not pay? Well, nothing. This is how DeFi works. How do we know the price of an asset on blockchain or in chain? So you can use proof of reserve feeds, or you can just grab it like like I did it because there is no proof of reserve feeds for this asset, so I used any API, but that's not how you're going to usually do. You're going to just use proof of reserve feeds for this, which is similar. Actually, the usage in code is the same as price feed. We're just going to deal with different thresholds and decimals, etc. Cool. Any final questions? We have 1 minute left. And yeah, I don't. If let's see if you have any further questions, how you can contact me. Let's see, Twitter. Oh, it's over here. Yeah. So if you have any further questions, this is my Twitter. So I'm gonna just share my screen for the final time. So Andre_dev. So any final questions, feel free to just tweet and tag me, and I'm gonna answer because messages are disabled by default. So don't worry, I'll answer either here or on Discord. So yeah, that'll be it. That's it. Yeah, hi Tatiana. I think we're right on time.
Awesome. That was amazing. Thank you so much, Andre. And now you guys know how to reach out to him after the fact. So well done joining today and sticking with it for an hour and a half. Very good. Just a kind reminder that we will have another session later today, 2 o'clock Eastern Time. It will be Intro to Swan Chain with Charles Cow from Swan. So come join us and learn what Swan Chain is all about. And with that, have a great rest of the day, and we'll see you later. Thank you so much, Andre. Bye.
Thank you.
Bye.